Looks like it's going to rain today. Let's talk about water. Hello, and welcome to How's H2O, where we show you what's up with water. I'm your host, Anna Horowitz. I love water. Water is everywhere. Water is essential for life on Earth. Did you know that 70% of our planet is covered with water? And did you know that 55% to 78% of the human body is water? Wow, that's impressive. Today, we will be studying why oceans and saltwater bodies of water do not freeze thoroughly, but lakes and freshwater bodies of water do. This winter, I went to Alaska and captured these images. Look at the differences between the lakes and the oceans.
Yo, VIP, let's kick it. Ice, ice, baby. Ice, ice, baby. All right, stop, collaborate and listen. Ice is back with my brand new invention, something.
Let's get some background knowledge. Water, or H2O, has a freezing point of 0 degrees Celsius. It is made of 2 hydrogen atoms and 1 oxygen atom. Salt, or NaCl, has a freezing point of 801 degrees Celsius. Sodium chloride forms crystals with face-centered cubic symmetry. Saltwater is salt dissolved in water. The sodium and chloride become independent atoms. So, saltwater is just water with sodium and chloride. As an intellectual professional, does salt and water affect the freezing? Now, let's make an experiment. I'm going to examine the different effects of when there is or isn't any salt in the water. For this, I will need the following materials: a thermometer that reads below -10 degrees Celsius, a 250 milliliter beaker, 4 10-ounce plastic cups, tap water at room temperature, tablespoon, iodized table salt, 1 Sharpie, 1 clock, and your home freezer. Don't forget your safety equipment, because salt in the eye makes you cry. First, label each cup with either A, B, C, or D. Then, fill each cup with 100 milliliters of water. In cup A, we will add no salt. In cup B, we will add 1 tablespoon of salt. In cup C, we'll add 2 tablespoons of salt. And in cup D, we will add 3 tablespoons of salt. Now we are ready for the freezer. Now, we will be checking on our experiment every 20 minutes for the next 2 hours. At 20 minutes, I'm taking my first observation. In conclusion, water with salt freezes at a lower temperature and at a slower speed in a household freezer at -10 degrees Celsius compared to the same amount of water without salt. With every tablespoon of salt added to 100 milliliters of water, the freezing point decreased by 2 degrees Celsius, as seen in the data table. Is there a connection with global warming and the decrease of polar ice caps? Reviewing the data and observation table, an interesting and new topic of interest to further research will be to examine the different ice structures and density of salt in freshwater.